Good afternoon, everybody. This is Truth Seeker Atheist here, and I think this may end up being a bit of a lengthy video, but I hope it may be helpful. I'm shooting outdoors for the first time. You can see it's a beautiful day. I wish I could angle that camera a little better so that you could see a little more, but unfortunately, I'm not going to be much on screen anyway. I'm just basically introducing this. Now, I was born and raised a Bible student, and I guess that's something that may to many Jehovah's Witnesses kind of they might be a little bit skeptical of the claim, because the governing body, they portray a history that's is really lies by omission, because of the fact that they don't talk much about the true occurrences historically, what happened between Joseph Rutherford and the majority of the Bible student movement that he headed up after Charles Russell died in 1916. Almost. It was October 31st, 1916, so it was only a couple of months until the 17, when Joseph Rutherford became president around early January of 1917. That was when they used to hold their annual meetings in Pittsburgh. So, I was raised, Bible students are like Jehovah's Witnesses, fundamentalists. They believe in the literal interpretation of the Bible. And I was born and raised with a pretty fundamental point of view of how the earth was created. They did have their own nuances to the book of Genesis, is because Russell wanted the appearance of being scientific. If you look at the photodrama of creation, he introduces it as a religio-scientific presentation, and it was an 8-hour epic drama of his view of human history, from the time of creation to the time in which God reestablishes the paradise lost by Adam and Eve. And his view of creation was a slightly different view from the literal 24-hour creative day perspective of the fundamental evangelical Christians. But it isn't really an old earth viewpoint either, because it isn't old enough. Russell, and he never really, the explanation for how he came up with this is somewhat vague. He never really shows why he believed it this way, but he believed that each creative day was 7,000 years in length. Now, 7 is a Bible number, and but the Bible says that a day with the Lord is as 1,000 years, both in in Peter, I believe it's 2 Peter that he says that. That the Bible makes reference to that time frame. Also, there is a reference to the 1,000 years in Revelation. And it says Revelation 20 that the those that were slain and for the word of Jesus were resurrected and ruled with him for 1,000 years. And so that's where the Bible students and hence Jehovah's Witnesses came up with the 1,000-year kingdom. And since then, there have been other Christian organizations, many of them independent, non-denominational Christians, that also believe in the millennial period. In fact, millennialism was a brand of religion that arose in the 19th century and was quite popular in both the North and the South during the Civil War. Noted historian David Blight, Civil War historian David Blight, makes note of that in his lecture series on the Civil War. It's quite interesting. That's a fascinating. Recommend people to. You can get it's on diskette. You can play it on CD. But anyway, I enjoy Civil War history. Just a second. I gotta stop. I just got a note here that my battery is at 9%, and I thought I was plugged in. So I will plug in, and I will be right back. All right, back again. Sorry about that. So anyway, I was raised with the understanding that each creative day was 7,000 years long. Russell thought that he liked things in nice, neat packages. He didn't like time periods to be unspecific. He thought God was the Swiss watchmaker that made everything with a precise what am I looking for? I hate this aging business with the forgetting the words, but the symmetry. That he had this fixation on symmetry, and that God had to make that each creative day 7,000 years long exactly, and each 7,000 year day there were subsequent days, each being 1,000 years, because the Bible in Second Peter says that that a day with the Lord is as 1,000 years, and so he says that I don't know how he makes this thing jive and justifies it. It just makes no sense to me that each creative day is a creative week in itself, and that there were 49 creative days, and the kingdom, the 1,000-year kingdom, would make the 50th, and that would be the 50th Jubilee. He tied in all of these things, and it was complicated, and it made no sense, really. And he bought into some strange stuff. I mean, not only the pyramidology, which, because unfortunately, I mean, you can have hacks in science, and Charles Piazzi Smythe, who really promoted the pyramid as something, a construct of God, also happened to be the astronomer royal for Scotland, and now he was just a crank. There was a fellow by the name of Charles Taylor who wrote a book in a little before the 1860s. I think it was the late 1850s, early 1860s, about the Bible, and he came up with something called the Pyramid Inch. and Smythe then went to work with all these crazy measurements, and Russell bought this thing hook, line, and sinker. I mean, he was today he'd be the guy chasing down Bigfoot and cryptozoology and all that stuff. You know, that just they're people that just happen to be inclined towards that, and Russell happened to be one of those individuals. But his take, although he tried to sound as scientific as possible, really is not something that can be established and verified from a scientific point of view. And he based his understanding of the creation of the Earth not only from his own chronological point of view with the 7,000 year creative days, but he also bought into a theory that of the Earth's formation that was promoted in a pamphlet by a school teacher by the name of Isaac Vail, and it's called Vail's. They call it the Valian theory. It's not even a theory. It was a hypothesis. And again, this is something that Christians fail to differentiate. They don't understand what a scientific hypothesis and a scientific theory really is. And so this is something that has been of controversy between atheists and Christian apologists for many years, and it's still something that's talked about. And many atheists utilize the theory of gravity, the scientific theory of gravity, because everybody understands that if you drop a rock and it hits your foot, it's going to hurt. That the rock isn't going to go up or sideways, or it's going to go straight down when you drop it. And so it seems to be an inherently understood thing that gravity exists. Fortunately, gravity, from a scientific point of view, happens to be the enigma for scientists in many respects, because we have two prevailing theories of the universe and the way the universe operates. And when you have a scientific theory that explains how the universe works, it should be comprehensive. So from the smallest entities in the universe to the largest, the theory of everything should be able to explain it all. And we don't have that today. That's been something that's been elusive to scientists now for the last 100 years. And I'm not going to go too much into the details of that right now. I do a little bit in my in the screen presentation that I will add to this introduction. But we have two basic theories, physical theories, that describe the universe. One on the extremely small scale, and that's quantum theory, and one on the extremely large scale, which is general relativity. And general relativity is the cosmological theory that describes gravity, describes the interaction of planets and galaxies, how the universe expands. It's the fundamental theory of the whole cosmos at large. And it's highly successful, and we couldn't do without it today. I mean, we use the relativity is used in high energy physics, where they accelerate particles to near light speeds, and they have to use relativity. In the making of the atomic bomb, it was critical. But also in GPS, it's critical because special theory of relativity and time dilation impacts the clocks on the satellites that orbit and give us the positions of our location on Earth, and we really do depend on these things. I mean, how many people read a map? I mean, we've got kids today that can't read the Constitution in its original script because they've stopped teaching script in school. And we have, I mean, it might as well be hieroglyphics, the Constitution of the United States. And, without it having, being written in print, these kids go to the National Library and they're not going to be able to look at the actual draft of the Constitution and be able to read it because they don't understand script. It's something that's a lost art. So are reading maps. And we depend so heavily on the time-saving aspects of the GPS. Has just gotten so good. But when we realize that it's based on science that tells us something that's fundamental about the universe, and that it tells us something that runs contrary to what the Bible tells us and how the earth was created. I mean, all of science is there's so many different sciences. I mean, the ones that for some reason affect Christians the most is the theory of evolution, and it's just the theory, and they don't understand basically what a theory is from a scientific point of view, and atheist apologists or atheists go on to explain, well, it's a theory is as sound and solid as the theory of gravity, and hoping that that's fundamental enough for people to understand. And yet, they're not that. It's not that compelling an argument. You're just not going to get people to understand and be reasonable about things if they don't want to be reasonable. Humans have this tendency to want to put themselves into denial because it threatens their sense of self. You see, that's the problem. That I think religion has dug itself in and has isolated so many of us from the world of the broader world of free thinking that it causes us to be fearful, to think beyond what has been told us, and because our sense of being, our sense of who we are, has been defined from the time we were born by the belief systems that we were raised to believe. And in my case, it was all the crazy stuff that Charles Taze Russell had come up with about creation. And I was raised to believe in the veil theory, and it's not even a theory. It was never even taught in universities. There were no tests. That nobody accepted it. Isaac Vail was a crank, and he was a geology teacher, delving into the world of cosmology and astrophysics, and talking about how the Earth was made, and there was no basis for his ideas except that he was a very strongly devout Christian, and he thought that he had come up with a came up with the means by which the earth was made that was consistent with the Bible. But Russell latched onto it and said that this was science, without knowing really what science is about. So I thought I'd make this little video just to present. Maybe I've gone a little too above people's heads. I don't know. But I pick on the flat earthers because that really bothers me. There's a Forbes article that I'm going to pop up on this video that earlier this month, it was published earlier this month, that a survey was established that involved thousands of people, and the younger generation, the millennials, between 18 and 24, only 2/3 believed that the earth was round or spherical, and the remainder, that's a third, believed that the earth was either flat or they didn't understand, and that's, to me, that's terrible. So I picked up, flat Earth is something that was established 400 or 500 years ago. I mean, Columbus was one of the few individuals that based his ideas that, if you go west far enough, you come back to your starting point. He believed in a spherical Earth, and he thought that it was an easier way to Cathay, Japan or China, where they could get spices. He didn't know that North America and South America actually stood in the way. And when he got to North America, in fact, Columbus never thought that he had discovered a new continent, and he had always thought that he had accomplished what he had thought, that he was that he had gone to Cathay. But anyway, that's beside the point. He did have the concept of a spherical Earth at a time when the church and the rest of the world were reluctant to accept that, and the majority of people believed in a flat Earth because it looks flat. And so I pick on that, and I use that as an example of how you can compare phenomena. What would you expect if you had a flat Earth? What you would expect, if you stand at the seashore and you notice that the ships, as they come in, you look out to the distance and you see the tops first, and then you see an increasing amount of the ship until you see the whole ship. And what would cause that, And so you establish your hypothesis, and then create the mathematical model for your hypothesis, by which you can test certain results and predictions from the mathematics. Now, the mathematics that I use isn't very complicated. It's simply the Pythagorean theorem, but it's the same idea as used in science at all times. And the fact that we unfortunately have thousands or even millions of people that believe the Earth is flat, maybe it is relevant. And so I derive the mathematical equations that are based on the hypothesis, and then establish experiments by which the hypothesis can be tested. And once you have the evidence, then you've created your theory. And the more that you establish the evidence by a variety of different experiments, the more you establish your theory to the point of fact. But you don't ever call it the fact of this or fact of that. In science, the theory is established as rigorously as a fact. So that's the point of this little video, and I hope it's relevant. I know it might be a little long, but I think it's useful, and I really hope that you guys listen to it and that it's beneficial, because it's how the scientific method works. Of course, I didn't add peer review into the whole thing, but when you're a true scientist, you would present your evidence and your predictions and the evidence and how it stands to the predictions, and you would write it up as a journal, part of your, and have it published in a journal where it's then peer reviewed. And people would then come up with other experiments to test it, and that's how science works. But anyway, I think the flat Earth thing is a nice thing, and I think it gets away from it shows how science operates, and it does not address all of this conspiracy theory stuff. I don't know what it is about the human nature, but humans love conspiracy theories, and I don't know why. It's a part of human nature, and I don't know. That we didn't go to the moon. We didn't. The Earth is flat, and it's surrounded by some giant ice barrier wall, and all kinds of crazy things. And so anyway, I hope people get to understand this a little better, and also can see how science in general, and many branches of science, again, it wasn't evolution that caused me to doubt and question whether or not there was a God. It was the broader science altogether, the cosmology and quantum theory and geology, and it's all consistent with evolution, and it was a number of things for me. It wasn't just one thing. It was all of science that finally allowed me to question the idea, the concept of whether or not there's a God that is interested only in the goings on of this planet. Because, this is a tremendously huge universe. And why would God only be interested in this planet? And if he's only interested in this planet, then are we the only ones in this humongous universe? And if we are, then why did he make this huge universe? And if not, then there are other millions of other intelligent civilizations throughout the universe, scattered. And if so, did God deal consistently with them all? Did they all go through what we went through? Do they all have the Bible? So, those are huge questions to contemplate. So anyway, I'm going to stop my dialogue right here, an introduction, and I'm going to bring you into the. Oh boy! Maybe I shouldn't be outdoors. That was a pretty big hornet. Anyway, I'm going to call it my intro quits here, and I hope that the rest of this is something that you can appreciate. So, talk to you later, and have a good day. Yes, this is a very disturbing situation. Earlier this month, there was an article in Forbes magazine about a survey that was performed on young Americans, on all Americans, I believe. And they found in this survey that only 2/3 of American millennials believe the earth is round. Now, when you have a situation like that, it's really hard to use reason with people. I listen to a lot of channels. Of course, I go by the name of Truth Seeker Atheist. I've only been an atheist for several years, probably no more than 4 to 5 years. I don't even think I went through an agnostic phase. But when I gave myself permission to think more broadly about how I was raised, what I was raised to believe, and what I learned in college, and how it really just doesn't coordinate. You hear an awful lot of atheists even who say that you can be both Christian and a scientist. And I'm not sure how you can really say that, because to be a Christian means that you believe what the Bible says is true without question. Now, the early Christians obviously would not consider anybody who didn't believe that the earth was made in 6 days, literal days, that God had stopped the earth. All of the Old Testament stories where strange and abnormal physical phenomena occurred. They believed in that stuff, and they believed in it wholly, and by making it allegorical so that you can make it consistent with your scientific beliefs is not Christian. It wouldn't have been Christian to the founders or originators of Christianity, and the many millions of Christians, fundamentalists, evangelical Christians today, believe in the Bible literally, just as the individuals who created the Bible did. They believe in miracles, they believe in magic. So anybody who tries to compromise Christianity and the Bible has to say that the Bible really isn't true. It's just allegorical, and that it's a moral lesson. But that's not what the creators of the Bible meant when they created the Bible. Of course, they were 4,000-year-old people who live 4,000 years, so coming out of the Bronze and the Iron Age, and they didn't have science as we understand it today. The disturbing thing is that it seems to be that we're retrogressing back into ignorance, and there is no compromise between Christian beliefs, religious beliefs, and science. They're just incompatible. You can say that I have altered my religious beliefs so that they're consistent with what is been found in science, but it's not what the founders of Christianity had in mind, and it's not what hardcore fundamentalists believe today. I mean, you have very vocal Bible apologists who have quite a strong influence over a great deal of people. Now, you can't, I understand that Richard Dawkins is hesitant or doesn't want to debate Christians because he doesn't want to even put Christianity on the same footing. There's the same level of credibility. By debating, lends credibility to the Christian concepts, and you just don't do that. Science isn't in the habit of debating any thought or theory or hypothesis that comes out. They debate serious challenges, let's say serious concepts that may alter our understanding of science and may alter our understanding of the natural world, and that's the way it should be. There should be this standard, but just anybody's thoughts shouldn't stack up and be given any kind of weight or credibility to anybody else's. I mean, there's a whole degree of rigor to science that doesn't exist with the Wild West, anything goes sort of thing. And scientifically speaking, Christianity just has not proven. I mean, it just doesn't stack up to science. I mean, it can't explain a single thing about the natural world. There just isn't a single thing in the Bible that is science. And it's disturbing to see that we're heading back into a dark age, a period of time where Christians say, well, we deserve equal footing, we deserve equal status. We're going to slip back into dark ages. These devices that we use, the computers, the iPhones, the radio waves, the frequencies that we use to communicate through, all have a scientific basis. All of them have a statement about how the universe works and what the universe is really. I mean, so this is a computer. Yeah, so I have an iPhone, but the iPhone is a computer, and it's based on chips that have implanted in them billions of microscopic transistors, only microns in size and dimension. And these transistors act as on-off switches and duplicate or replicate the ones and the zeros for the binary language or the binary mathematical code that runs the algorithms for our computers to be able to operate and execute logical programming algorithms, things that we want them to do. Apps aren't just magic. Apps are programs, and the programs are written in code, and the code is executed physically on the chip, and the chip itself operates on the basis of quantum theory. And so fundamentally, quantum theory is how our computers, how our telephones that we carry around with us work, and quantum theory says something about the way our world works. And there are aspects of quantum theory that run contrary to the understanding of a world that let's say the Bible says that this is a world of certainty, that God, there's nothing uncertain with God. Well, quantum theory says that this world operates on a degree of probability, and that there is a degree of uncertainty in the way things are, and that's an inherent element of quantum theory. The orbitals of the positions of electrons around the nucleus of an atom are probabilistic, and so it's a statement, and using these things is only made possible by the fact that we have a fundamental understanding of the universe that just wasn't there before quantum theory existed. We could not have these devices if it were not for quantum theory. And quantum theory really came into being around, actually Einstein developed the quantum theory of light, and he won the Nobel Prize for physics for proposing quantum theory. But also there was the black body radiation in the 1890s that could not explain the distribution of the wavelengths and energy that came out of the black box, and there had to be the light had to be, the distribution of the light had to be quantized with a integer factor, and that was by Max Planck. He didn't really have a theory behind it. It was more of a mathematical fix at the time to make the math meet the physics, but it was the first step towards understanding quantum theory. And at the same time, there were experiments, there were phenomena at the macroscopic level that could not be explained. Most prominently was the ether experiments of I believe it was J.J. Thomson, Anyway, Michelson-Morley, the Michelson-Morley experiment, that was it, where they created the interferometer because up until the 20th century, all wave motion needed a medium in order to work. For example, when you throw a stone in water and you see the ripples move out in concentric circles, that medium is the water. The water carries the energy that was imparted to the water by the stone, and that energy gets carried through the water in wave form. So the water itself is the medium. Waves are also carried through solid medium. Earthquakes are waves through the rock, and there are compression waves. They're what they call L waves, longitudinal waves, and S waves, and P waves, pressure waves, and earthquakes need the medium of rock to transmit the energy, and it transmits the energy in wave form. But the medium is the rock through which the energy is transmitted. So when it came to light, physicists assumed that they understood from the time of Newton. Newton did experiments with light. He wrote a book called Optics, and he had demonstrated that waves, that light behaved in wave patterns. And because light behaved as a wave, physicists assumed naturally that there must be a medium that carries the light wave, and they called this medium ether. But nobody observed this ether. Nobody understood what this ether was. And by the end of the 19th century, there were experiments that were established to show and demonstrate that that light is carried by this medium ether. It turns out that the speed of the wave front changes. If you're in a boat and you're heading into the direction of the waves, you'll see a difference in a shift in the speed of the wave, and so they created this interferometer, which was to measure the difference of the speed of light in the direction of the Earth's orbit and in the direction perpendicular to the Earth's orbit, and they should have gotten a difference in the speed of light. Unfortunately, for them who believed in this ether idea, they did not measure any change in the speed of light, and that really befuddled many physicists, because all other wave phenomena except for light demonstrated this velocity change. So light behaved very differently, and so it created and cast a doubt on the concept of ether. It wasn't until Einstein who postulated that with the theory of relativity, that one of the fundamental axioms of the theory is that the speed of light is the only absolute in the universe, that no matter which direction you're moving in relationship to a source of light will always be observed to be moving at the same speed. So if you're in a reference frame, if you have a flashlight, and you're in a rocket ship heading toward another rocket ship that's heading towards you at a very high speed, you're not going to see an increase in the speed of light in the flashlight that they're holding. The light will be measured at the speed of light, not the speed of light plus the difference in the speeds between the rocket ships. Think about how strange that is. When you're in a car on a highway and you're going 80 miles an hour, and somebody in the opposite lane is going 80 miles an hour, your combined relative speeds would be 160 miles an hour. But that's not the case with light. Light would only the relative speed between light from two sources going in opposite directions would be the speed of light, not double the speed of light. So that's a very odd postulate. Now there is a shift, and that it's a form of Doppler shift. It's not exactly the Doppler shift. The Doppler shift is that you'll hear the change in frequency, and the change in frequency is also associated with the speed of wave phenomena, generally speaking. So when a train is approaching you and it's honking its horn as it approaches you, the pitch of the pitch of the horn increases, and then as the train passes you, the pitch of the horn decreases. That's a change in the frequency because of the relative speed difference of the wave as it approaches you versus the wave regressing away from you. And that is Doppler shift in the classical sense, but light doesn't behave that way. The way that you observe light's Doppler shift is in the shift of the wavelength of the actual wavelength itself, which is what they call a shift to the red or a shift towards the blue. But it doesn't change the speed of the light. Whereas in most wave phenomena, all other wave phenomena, the Doppler shift is associated with the change in measured speed. So the Doppler shift is for light is a much different phenomena than the Doppler shift in a train. They're not entirely analogous. Okay, let's just put it that way. So these experiments, these phenomena that scientists were learning in the late 19th century about light, about particles, and about gravity, and about light, were questions that couldn't be answered by classical physics and needed a new understanding, a new theoretical basis to understand these things. And that's where quantum theory came into being for the particles of, small particles, the atomic model with the nucleus made of protons and orbital electrons, and all the particles that have been postulated since as a result of quantum mechanics, the Schrödinger wave equation, and then you have the theory of relativity, and the first theory of relativity was Einstein's special theory, where you were looking at relative reference frames, moving at inertial speeds. In other words, they were not under acceleration. They were moving. These reference frames would be moving in relationship to one another, but they weren't under an acceleration. The general theory of relativity is when you add an accelerating component to the relative reference frames, and then that changes things drastically, and it makes things very complicated, much more complicated, and it really comes out to describing gravity. So quantum mechanics describes one element of the world, which is the small, the very, very small, the protons, electrons, neutrons, particle physics, and then relativity describes gravitational attraction, and that's the four. That includes when you look at quantum theory and relativity, you're looking at the four forces of the universe. Three of them associated with quantum theory, which are the weak force, the strong force, which is the binding force of the nucleus, and the electromagnetic force, which is light. And then magnetism and electricity are actually flip sides of the same thing. So it's called electromagnetic force. And then on the macroscopic scale, the cosmological scale, the only force that really matters in the motions of large objects with galaxies and with planets and planetary systems and the moons and the orbits of the moons and so on, is gravity. And general theory of relativity explains that. And what scientists have been doing, what physicists have been doing for the last 100 years is trying to reconcile the two ways of looking at the universe. You see, because gravity is not well explained in quantum theory, and none of the quantum phenomena is described in relativity, and so you have these two physics, and there's been the main attempt of physics, the field of physics, has been to reconcile the two viewpoints. Now the thing is that many things require both theories. For example, in nuclear physics, when you have an atomic cyclotron and you're using, let's say in Brookhaven National Labs, you're accelerating the nucleus of gold atoms. Gold is a very heavy element, and you're using magnets, supermagnets, to accelerate gold nuclei to speeds very close to the speed of light. Then you're entering into the realm of relativistic physics. And so not only do you have quantum mechanics to consider, but you also have relativity to consider, and both are used, but it doesn't necessarily say that you have a single theory from which both derive. And that's the problem, that there isn't a theory of everything out of which quantum theory comes as a special case and relativity comes out as a special case. So that's been the main aspect, the main goal or of physics for the last close to 100 years. And it's not that these these areas of physics are wrong. I mean, the quantum theory has allowed us to make amazing progress in technology. All of these computers, all of our electronics, our solid state electronics that are based on quantum theory completely, and then the larger aspects of the cosmos are explained entirely by relativity, and relativity has done a wonderful job of explaining the universe, even to the point of explaining the accelerating expansion that they've recently found through the Hubble telescope. That expansion rate, the acceleration of the expansion rate of the universe, is actually Einstein's cosmological constant, and that is an amazing thing. Actually, Einstein thought the cosmological constant was his greatest blunder when Hubble had shown that the universe is expanding. Edwin Hubble, who was the famous astronomer who first discovered galaxies, and not only that, but discovered that all galaxies are moving away from one another at a considerable rate, and that rate is called Hubble's constant. Well, now they know it's not constant, but it's an accelerating factor. So this article, though, is saying that we're being thrown back, that 2/3 of Americans, millennials, the younger people, 18 to 24, believe the earth is round, and that means a whole third either don't know what they believe or they believe the earth is flat. Now, this is a theory that we thought was settled. I mean, I know many atheists discuss the science and its let's say contradiction to the Bible, inconsistency with the Bible, because apologists argue, well, it's just a theory. Evolution is just a theory. For some reason, Christians just focus on evolution as if evolution is the only scientific branch that discredits the Bible. For me, it was physics. For me, it was relativity. For me, it was quantum theory. Now, yes, I studied physics in college. I was a physics major, and my bachelor's degree was in physics. But it was the physics of the universe and the fact that the Bible stands inconsistent with physics more so than anything else. I guess it's just that it's a little more obvious maybe for most people, because we have a world we with a diversity of life, and the Bible is the only thing that the Bible really focuses on is the diversity of animal life, and claiming that God created that diversity and created man. And so they focus on evolution, and they come up with all kinds of arguments against evolution, but there's much more in the scientific world that stands contrary to what the Bible teaches, just from a physical point of view. And that's what influenced me. Evolution didn't disrupt my faith. It never did. I always thought that, as a Christian, that possibly, God could use evolution as a means of creating diversity. I never thought that evolution was really that big a deal in terms of discrediting the Bible. I thought the other branches of science were more powerful in their arguments against the validity of the Bible. And it looks to me that we've got a large segment of our society that are reverting back to pre-Columbian. When I say Columbian, I'm talking about Columbus. And so many. We were taught that Columbus proved the world was round, and that by sailing from east to west, you could return back to the east again to your port, because the Earth was a sphere. And it wasn't just Columbus. Columbus just said he was he was one of the adherents to that idea. But there were the idea that the Earth was not flat was not something that was introduced by Columbus himself. And I thought that this whole flat Earth, you wouldn't think that there would be that many individuals who adhere to this flat Earth concept, but this idea that the Earth is flat goes back to Aristotle and the Church, the Catholic Church, had adopted that idea, that concept from Aristotelian theory in the days. And there were Greeks who also postulated that the Earth was curved, that it was round. And but I thought that this is something here that can be demonstrated to show. I think this idea of the flat Earth as a perfect way of showing how a theory develops and is supported, and what we're talking about when we talk about scientific theory. Now, the reason people thought, and let's say Aristotle thought, that the Earth was flat is because they had no other evidence that suggested that the Earth was anything but flat. You can't see the curvature of the Earth. The Earth is so large by comparison to us and our size. We can't detect the curvature of the Earth visually very well. I mean, it's not like we can look at the horizon and see the Earth curve. But there are ways in which this let's say theory can be tested. Now, with this flat Earth versus let's say round Earth, we can say, well, all right, let's take a look at what the two theories let's take a look at what the two theories predict. Okay. First, we just accepted for thousands of years that the Earth was flat, and so the greater masses of people just accepted it. It was taught as dogma by the church. There was nothing called science or a scientific community for thousands of years to contradict the church. The church was the only organized authority at the time, and they bought this idea that the Earth was flat. Of course, there was a religious component to this, because the Earth was, according to the church, the center of God's universe, and so God Himself made the Earth the center of His focus, and so it made sense that everything else, that the Earth be at the center of God's universe, because we were the most important things in His attention. But there were some people who took a walk down by the seashore, and they took a notice that there were ships out on the sea, and that when the ships were far out in the ocean, they could only see the tops of the ships. Now, this was something that was made a little easier. You could see it visually with the naked eye, but when the telescope was invented in the time of Galileo, you could see this more readily, this phenomenon more readily, that as a ship approached harbor from the sea, you first saw the tops of the ship, and then as the ship approached, you could gradually see more and more of the ship, and then at a certain point you could see the entire ship, and or at least most of the entirety of the ship. And so the people were thinking about that, and they wondered what would cause that. So I'm gonna, here we go, format shape. So they postulated that, well, what could be responsible for this phenomenon? Every time I go to the shore, I notice that this happens. If I lived on a flat Earth, due to perspective, if the ship were far away, I would expect the ship to be smaller. But I would expect that I would be able to see the entire ship. That there would be no horizon over which the ship would come. So the explanation for a ship appearing in the manner that it always seems to appear every time I watch it coming in from the ocean is that the Earth is round, and that the ship is coming over the horizon. It's appearing over the horizon. So I'm gonna make that a little heavier. Okay, and so how how can we explain that? Well, we made this postulate. We saw the phenomena, the ships coming over the horizon. We came out with a hypothesis that the Earth was round and not flat, because when it's far away, we don't see the whole thing. We only see a part of the ship, and as it gets closer, we see more and more of the ship. So we come up with a hypothesis that it's actually coming over a horizon. What would create a horizon? It would be a round Earth. So, knowing a little bit of mathematics, I would then, I'm going to do the best I can, just eyeballing the center of this thing. I would then use my knowledge of mathematics to create a mathematical model, of the concept of a round Earth. Okay, so from the center of the Earth to the surface of the Earth, if the Earth were round or sphere, because I noticed that this occurs no matter what beach or what direction I'm facing. If I'm facing east to west, ships do the same thing. If I'm facing north and south, the same thing occurs. So that would only happen if the Earth were round in every direction. And thus, the only object that I know of that is round in every direction, well, is a sphere, or let's say an ovoid shaped like an egg. But we can modify our theory. Let's first assume that the Earth is a sphere, a round sphere. And so, knowing a little of the mathematics, I use my knowledge, and they had this knowledge of mathematics even in Galileo's day, and even in the 1400s they had a degree of understanding of trigonometry. Now, the key here is my eyes are set at a certain distance h above the Earth. Okay, and I'm standing at the seashore. I'm gonna make that a little larger. I'm gonna say this is H. I'm gonna format that so it doesn't block out. No fill, and line color, no line. Okay, so that's me standing there. My eyes are an H height above the surface of the Earth. Okay, now again, this is just a conceptual model. This isn't a real model to scale, obviously. Okay, so you know what I'm going to do? I'm going to just make a copy of that. Copy, and let's paste. And what I'm going to do is I'm interested in the horizon, the point at which the horizon is visible to me. Okay, and that is when you make a tangent point. Okay, So I'm going to take this out a little further. Okay, so that's not exactly on the tangent point there. Okay, so the horizon is the tangent point. Now, beyond that point, anything that's below this line of vision, I can't see. So this area where my little cross is, I can't see from this point. All right, that's below the horizon. Okay, so what is the distance of the horizon? So let's copy, paste. All right. I'm going to, again, use some of my mathematics. All right, I'm going to just... that's not exactly there. I'm too finicky. Okay, so here we go. Notice one thing here, that from the tangent point of my line of sight is perpendicular, okay, to the radius. So this is the radius. Okay, copy, paste, paste. Okay, this is the radius of the Earth, and this is the radius of the Earth. Okay, so I use a little trigonometry. I'm going to call this distance to the horizon. I'm going to call that D. All right, and what I have is a little bit of algebra. This was known as far back as the ancient Greeks. It's called the Pythagorean theorem. So what we're going to say is that the square of the base times the square plus the square of the height of the triangle is equal to the square of the hypotenuse of the right triangle, and that's the Pythagorean theorem for right triangles. So we have r squared. I'm going to just format that a little bit, plus d squared equals r plus h squared. All right, now what we're going to do is we're going to superscript that. We're going to superscript that so that we have a properly written equation. Superscript. Okay. Pythagorean theorem. Okay, so what are we interested in? We're interested into the distance to the horizon. Okay. Now, the distance to the horizon, d, is equal to, I'm going to insert a symbol. I don't like the limited symbols that that are given to us in this software package, but Excel is limited. Well, you know what I'm going to do? I'm just going to copy. Copy. It doesn't work, does it? Copy. Here we go. All right. Now, this part okay, let's get rid of this. All right, now we got to remember that all of this is under the square root sign. So that's the formula. Oh, unfortunately, I lost my formatting. Oh, terrible. All right. Format. Okay. And okay. All right. So that gives us the distance to the horizon. All right. Now the average of the Earth's radius. This is the Earth's radius equals 3,957.5 miles. My eye height, h, is equal to 6 feet. All right, this is in miles. Let's remember that this is in miles. All right, let's spread this out a little. It reads a little easier. Okay, same with this. But 6 divided by 5,280 feet per mile gives us, let's see, we want to format that so that we can see the numbers. We'll go out a bunch of decimal points. There we go. So h equals that. All right, let's just bring all these over so it's a little more aesthetic. Okay, so this happens to be miles. Okay, so r plus h, r plus h is equal to all right, we're going to have to get a new cell. Just see if that, okay. equals 3957. And you know why I say average? Plus 0.0011364. Okay, miles. All right, the reason I say that this R is the average, this 3,957, is that the Earth isn't actually a perfect sphere. Because of its rotation, the Earth bulges out a little bit more at its equator than it does at the pole. So the pole-to-pole circumference of the Earth is smaller, shorter distance by some, I don't know, 50 miles than the Earth's radius at the equator. And so I just took the average of the two. It doesn't make really much difference, even if I use one or the other. It really, the difference is so relatively small that the Earth is in essence a perfect sphere. You're really not going to notice it. Even mathematically, it's not going to make much difference. So, plugging in those values into our equation. Let's see, R squared is R squared, and I'm going to make that a square. I wish they made this a little easier to do. Word they do. They have a R squared is equal to how do you like that? I gotta bring that down. That's weird. Gotta take the superscript off of that. Okay, R squared is equal. Okay, and what we're going to do is equal to 3957.501 minus raised 2 minus 3957.5 squared. Okay, what did I do? Oh yeah, okay. Raised to the 0.5. Okay, that is our formula. Okay, so the distance D. Actually, I calculated D. So let's just unfortunately, D equals 2.81 miles to the horizon. If my eyes are 6 feet above the water's surface, the ocean surface or a lake, the horizon is 2.81 miles. So this means even you could establish an experiment on a lake. Lakes are a little smoother usually, and the than the ocean. The ocean, you can have 6-10 foot swells, but on a lake that's 5-10 miles long, you can establish an experiment. You could put a boat that is some height, maybe 8-9 feet above the water, its top deck, and then you can demark a vertical line down the side of the boat, and paint delineated markings, half-foot intervals, maybe inch intervals. Set up a telescope at a certain height, 6 feet above the water, and then take the boat out 4, 5, 6 miles away, and then see what using the telescope, mark the level that you can see right at the point where you can't see any more of the boat, the part of the boat that's below the horizon, and then see if that agrees with what you would mathematically expect what this distance would be that you weren't supposed to be able to see. And that is one way of testing whether or not the Earth is a sphere. And you can do this, in any direction. You could do it north, south, east, west, because the Earth is a sphere. There will always be a horizon. So you have now a phenomena that you observed, you postulated, you created a hypothesis that the phenomena was that you watching approaching boats, and you only saw a portion of the boat, and increasing amounts of the boat as the boat approached, and that's not what you would expect with a flat Earth. So you postulated that the Earth was round, and using a little mathematics, you can derive equations that would predict results of mathematical results of your hypothesis. If the world were indeed round, what would I expect? And then you can create a test to see if your hypothesis holds mathematically, and if the results from the mathematics is indeed correct. And if it does support, then you have evidence that tested your hypothesis, and now you have a theory, because you've been able to provide a line of evidence to support your hypothesis that the Earth is round. Now, another way of coming to let's say this conclusion is let's borrow this and go to another sheet, paste. Okay, now we'll shrink this down a little, and I get rid of the grids. Okay, I'm going to make this a little larger. 36. Okay. I don't know what happened there. 48. Huh. Something is really weird. Well, anyway, what we'll do is this. We'll just we'll make this round a circle. Let's make it a little smaller. All right. Okay. Now here's another experiment. Now this is something that was actually done by the ancient Greeks. Now there was a Greek in Egypt who performed this experiment. Now, what we can do, because one thing that we know is that the Earth is angled. It is on an angle it rotates about an axis that's 23.4 degrees off the perpendicular between the Earth and the Sun. So the plane between the Earth and the Sun is well, let's copy some lines. You know, tell you the truth, I'm just going to copy this and just use the same sheet. Alright, paste. Okay, so now this way I can go back and I can steal things that I've already drawn. Okay, copy. Now the Earth is, it rotates about an axis. Okay, so what we're going to do is we're going to just conceptually show the idea. I'm not going to be exact. Okay. All right. Let's. All right. The Earth rotates about an axis that is about 23 degrees off the plane of its orbit around the Sun. And that accounts for the seasonal variation that we have as we go about the Sun, because we get more direct sunlight in the summertime and less direct sunlight in the wintertime. In the northern hemisphere, that is above the equator, we could call that the center of the Earth there. And the Sun, this represents the plane of the Earth's orbit. And let's say the Earth is orbiting towards us out of the page. Okay? And the Sun is, well, I don't know if I need to draw it, but we will, just to make things a little. Okay, Sun. The Sun's over here, 93 million miles away. Okay, this is really not to scale. But by the time the Sun is so far away that all of the rays of the Sun, if we want to call them that, are coming directly to the Earth. Paste. Okay, so the rays of the sun will always be perpendicular to, will be parallel to the plane of the Earth's orbit around the sun. All right, and we'll just put format shapes. We'll put arrowheads to show the direction of the sun. And oops, I didn't do that, did I? Format shape, arrow, blah. Did the arrow show up? Why not? End type. Let's see. That's weird. Oh, you know what it is? They're so small that we can't see them. Alright, well, we'll forget about it right now. None. None. But the important thing is that we understand that the direction. Let's see. The direction of the sun's rays are in that direction. You can't really see the arrowhead there very well, so let's forget it. I can always make my own. And okay, copy, paste. There, we got an arrow, so I can and if I do page layout, I can group it. Now I got an arrow. So the sun's rays will always strike the Earth in the same direction. So you can copy, paste, paste. So we got the sun's directions always in the same direction. As it strikes the Earth, because the sun is so far away. It's way out there. It's 93 million miles away from the Earth. So all of the sun's rays hit the Earth, and the Earth is tiny compared to the sun, in the same angled direction. And we could utilize this, okay? Now, obviously, as the Earth orbits the sun, and just thinking, that the orbit is towards us coming out of the page, we can envision that this angle, when it's on the other side of the sun, is going to be facing away. Right now, this is summertime for the north because this angle is towards the sun. Okay. Now, there is a band around the equator, and the Earth's equator actually is going to be copy, paste, if I want to, I just want to be technically accurate. Come on. The Earth's equator is going to be something like more like that. Okay, so between summer and winter, there are going to be lines. They call them the Tropic of Cancer and the Tropic of Capricorn. Copy, paste, paste. And they will each be 23 degrees north above the equator and 23 degrees south of the equator. Now, in the summertime, the Tropic of Cancer, which is the northern tropic, will be directly in the plane of the Earth's orbit. So the sun's rays will strike directly down from overhead. In other words, if you stuck a pole in the ground that's perfectly straight, perpendicular to the Earth, you will not see a shadow. Because on the solstice, the summer solstice, June 21, the sun will be directly above the Tropic of Cancer. The same goes for the Tropic of Capricorn. The only time that the Earth's equator is at the center of the plane are on the equinoxes. So you have 2 times a year, March 20th or 21 and September 20th, when the equator is actually in perfect line with the orbital plane of the Earth. So I just wanted to mention that, because if you can set up an experiment. If you lived in the northern hemisphere, it might be a little easier to do this at the Tropic of Capricorn, because it's 23.4 degrees north, okay, which is a little further south than Florida. Miami, Florida is about 25 degrees above the equator, and let's see, Puerto Rico is 18 degrees above the equator. So somewhere between Puerto Rico and Miami is the Tropic of Cancer. And if you put a little pole in the Earth, okay, I'm gonna kind of simplify this drawing. If you remember, this is the summer solstice. If you put a pole of a certain height at the Tropic of Cancer, and it's absolutely perpendicular to the Earth's surface. Come on, this is getting a little harder. All right, I'm gonna format shape. Oh, wait a second. Size and position. Size and position. I can make this lines, size, properties. Okay. I thought I could create. I could. I thought I could, width, yeah. I could shrink this. There we go. I shrink it. Should be there we go. It's pretty much straight. Okay. Alright, so I've planted a pole in the earth at the Tropic of Cancer, okay? And it's June 21, the summer solstice. Alright, June 21, summer solstice. And I also have a friend of mine who, copy, paste, who sets up a pole at the 60, it's got to be perpendicular to the surface, up at the 68th parallel, okay, which when the earth is tilted, let's see, I want equals 45 plus 23.4. Whoops, what am I doing? Equals. I wonder why it didn't. Well, I guess I gotta open that up. All right. 68.4 degrees. All right, so that's what this will be 45 degrees on this. So at the summer solstice, our pole planted at the 68th parallel. Okay, copy, paste. All right, we're gonna. Okay, this is going to be exactly 45 degrees from the plane of the sun. Okay, copy, paste, and what that's going to do is it's going to cause it to cast a shadow. You see, because the sun's light strikes it straight. So copy, paste. We're going to cast a shadow and we're going to, all right, we got an arc here. We're going to format that so that we don't have a fill. Line style. Okay, line color. Okay. Alright, so we have an angle there. And because of trigonometry, copy, paste. We're going to flip this thing around. And we're going to make it smaller. that angle is going to be a similar angle. Okay, just by the rules of trigonometry, and they're going to be 45 degrees. Okay, and I don't know why that didn't make it larger. Okay, so that angle there is 45 degrees. I gotta make this fill, no fill. Okay, line, no line. Okay, so we got 45 degrees there, and copy, paste, and 45 degrees there. And what we're talking about is 45 degrees from the line of the sun's direction. Okay, so we're just the sun is here, but if we carried that straight across, that would be, that's the 45 degrees. Okay, so this angle will be the angle that that same angle, and we could use a little bit of trigonometry to show what the arc is between here and there, because remember, according to geometry, S equals R times, well, we got to use a symbol, insert symbol, theta. Let's use theta. That's what everybody else uses. So that's the formula for this arc distance. All right, we'll call that S. Copy, paste. That will be S. And of course, these distances are copy, paste. These are the radius of the Earth, R. R. Copy, paste. Oops. Copy, paste. All right. That's going to be R there. So this arc distance right here, this distance S between this pole and that pole will be R times 45 degrees. 45 degrees can be established on the summer solstice up at the latitude 68.4 degrees. Okay, so that's another experiment. And if we place poles stationed, these poles here, these guys, I'm going to maybe color them, format shape, let's say line color, make them red, and that I can't seem to. There. F4 won't let me do it. Format shape. Line color. Red. Alright. Okay. Those poles you could place at different longitudes. The longitudes are the lines that go from North Pole to South Pole. They divide the Earth up into those into quadrants. In fact, the Greenwich 0 degree longitude is Greenwich, England. That's where time zones are first begin, and the Earth is sliced up into 360 such longitudinal lines. You have the similar slices in parallel to the equator called latitude. You have longitudinal lines and latitude lines. Now, if you set up at each latitude poles, 68 degrees, and pole here, and as you approach noon on each day on the summer solstice, wherever these poles go, because the Earth rotates once in 24 hours, you can verify whether the Earth is indeed a sphere. So this is another way of experimenting. It would require some coordination to do. It's not as easy to do as the previous experiment that I mentioned. But yes, here's another way of testing the hypothesis that the Earth is a sphere. And it's based on certain principles and hypotheses that that the I don't know what happened there. That the Earth is a sphere, and so I'm gonna pull that way. And these are irrefutable lines of evidence. They're based in mathematics. They established the theory that the Earth is indeed a sphere. So for the flat earthers, how do you get around these? Because people have established that this is the case. I mean, there are well-known equations that have been tried and tested that show the distance to the horizon for shipping, and where that is important. Mainly for navigation, because they need to be able to see lighthouses. And let's say an 81-foot lighthouse, your eyes are 6 feet above the water, and how far away does the lighthouse have to be, or how close does the lighthouse have to be in order for you to be able to see it? And it turns out it's about 14.6 miles when you use the equations that I derived over here. So you could say that on this side over here, let's copy, paste. All right, paste. We'll kind of shorten it. Now you can see that, let's say I'm some distance. I got to keep that tangent. Okay, you can see that this distance from here now that's quite a bit higher than here. And this might be a lighthouse. So how far away does that have to be? Well, at 6 feet, the horizon is 2.8 miles. let's see, we want to get this down so that it's on the there we go. Okay, so this distance we knew was 2.81 miles, and we have to figure out what the distance to horizon for this would be. We would use similar equations for that distance. It turns out to be a little more than 10 miles, and then you add that to this, and you end up with 14.04 miles for an 81-foot high lighthouse. Now that can only be if you have a circular Earth, if you have a spherical Earth, because it's true for any direction. This relationship holds for any direction, and that means that the Earth has to be a sphere. So here I've derived various lines of evidence. So, it's really, really sad that something so simple, something so straightforward, something that has for hundreds of years been disproven, is so that there's so many people that don't understand this, and just outright deny the fact that the Earth is indeed a sphere, and they think that there's some giant conspiracy. Now, we can use rational thought and say, what is, how could you expect billions of people and hundreds of thousands of scientists and engineers conspire to say that the Earth is a sphere and be reasonable about it? But you see, that's the truth about anything scientific. Now, we have a world of devices. We have a world built on quantum theory, a world built on relativity. In fact, in relativity, GPS would not work. Nobody even uses a map today. There's a whole generation that don't know how to read maps because they depend on GPS. And the satellites, as they orbit the Earth, they're orbiting the Earth at about 17, 18, maybe 20,000 miles an hour, depending on how far out they are. I think the GPS satellites are some 20,000 miles above the Earth. They're pretty far out, and so they're not geosynchronous with the Earth, but they do have to. They do orbit the Earth at a high rate of speed, and over time, the very minute difference, that time dilation that is associated with the special theory of relativity, that time dilation, which is simply, I'm not going to write it out. It's easy to derive, and you can use trigonometry to derive the time dilation equation relatively simply. And the accumulated difference in time makes a difference in the position. So they always have to time correct for relativistic effects in GPS, because GPS is dependent upon the speed of signals, radio signals. Radio waves are basically light waves. They move at the speed of light, and the position on Earth is triangulation between three different satellites, actually four different satellites when you add elevation. But your position is triangulated by three different satellites, and the time differences for the signal to reach your GPS unit from each satellite. Now, that means that you have to be able to have very precise time measurements. And as the clocks on the satellites continue to orbit, they're going to change according to time dilation in a cumulative way, so that over a long period of time, they're not going to read the same as the clocks that are based on Earth. And so they have to correct for relativistic effects in GPS. And so we have ample proof of scientific progress, of scientific knowledge. That says something fundamental about our universe. Relativity says something fundamental about our universe. And you can't deny it. And yet, basically, people who are apologists to the Bible are great deniers, because they say, in essence, what they're saying is they're denying the accomplishments. They're denying the fact that the scientific method, as I demonstrated here using the flat Earth in a very simplistic way, with a phenomena, observing phenomena, making a hypothesis about phenomena, looking at the consequences of that hypothesis and what it would predict, and seeing whether or not those predictions come true. Using the predictions are made by the mathematical equations that I derive, and then I set up experiments, my boat experiment, my pole experiment, for establishing whether or not my hypothesis is correct. And if I have evidence that shows my hypothesis is correct, then I have a theory. And the theory is sound. The theory is based on the evidence and the mathematics predicted. And so that's what science is about. And that's the longer that people are testing theories, the more that theories, as they are either modified or as they withstand the test of time and the test of different ways of testing them, establish these theories basically as fact. But we still call them theories because that's scientific terminology. Just as your name is Sam or Fred, you see, it's something that we establish, we define it, and that's the way science defines the term theory. Now, there's no level of uncertainty once you get to the point of a theory. There's very little doubt of because the evidence to the rigor of evidence and review that has to go into verifying whether or not an experiment was fudged or whatever. A theory and its evidence meets many eyes for validity, and so it's well established and tested. And the longer that it's peer reviewed, the longer that a theory is tested from different points of view, the more established it becomes as fact. And that's where we are with most scientific theories. There's no, if we don't have evidence for it, we don't really have a theory. We have a hypothesis. So That's the simple. This is just a simple demonstration of a theory. And it's unfortunate that this isn't being taught, that this isn't how a theory is established, and how the whole scientific method works in a practical sense isn't made known to so many people. I mean, it's obvious that something is failing here. Now, it could be that it's just indoctrination, and that people are deliberately. I saw this show, documentary on one of these. I think it was Netflix, called Bible Camp. And when you isolate kids, when you isolate children, you don't give them a broad base of understanding, and then you infiltrate them over and over and over and over and over again with the same ideas. They don't have any other experience. This is then the only thing that they have is what they're being taught, and that's what is happening, is being done deliberately, so that they can hijack basically the minds of youth. And that's not freedom. That's not freedom of thought. That's not freedom. And it's certainly the wrong thing to do. And what's happening is we're being plunged back into another dark age. And it can happen. We can be plunged into another dark age, and it would be very dystopic, because the masses of people have come to rely on the devices, the cars, the planes, the GPS, the telephones that we have. And if people lose that science, then we're plunged back into a world of darkness. And the Bible, no matter what, will not tell us anything about how to recapture that science. It's something that we would have to relearn ourselves. And it took thousands and thousands of years for humanity to develop the scientific method. The scientific method is only 400 years at best, and religion, no matter what, but religious dogma goes back tens of thousands of years. Back in the days when there was when early Homo sapiens, hundreds of thousands of years ago, couldn't explain natural phenomena. The lightning frightened them, and they thought it was the gods were angry, so we can't do that. We can't do that to our children. We can't do that to people, because we need science. Without science, we're not going to survive. We just won't. And but anyway, that's all I have to say. I just wanted to, because there's so much discussion on this topic of theory and scientific theory, I just thought maybe this would be a nice way of presenting what a scientific theory is and how it operates. Of course, it gets a lot more complicated when you get into very esoteric science. It gets very detailed. Mathematics gets very, very complicated, very esoteric, but very insightful at the same time. So anyway, this is Truth Seeker, and I hope this has been a helpful video. So thank you all for your patience, and I hope this has been helpful in some manner to understand the idea and the concept of scientific theory. So have a nice day.